this video I hope to talk about two things. One is what is Arduino, second one is how Arduino communicate. Let's go. If I talk to you about what is Arduino, we will talk about Arduino Dual Board. Normally Arduino has 8-bit or 32-bit. For the Arduino Dual Board, it is a 32-bit microcontroller. Therefore, we're going to use the Arduino Dual Board to explain what is all the components and things like that inside the microcontroller itself. Minimally, you need three things. You need the power supply, external inputs, and the outputs. What are they? Power supply, as you know, is just the power supply. External input is what you input. You can input your switch when you press the button, something light up or whatever. So this is the switch, or your button, or your sensor. When your sensor sends anything, then something output. So your input is to sense something and send it to certain thing, and this certain thing will output. So therefore your output is what? Output your LED light. You can output any sound like hello, and interface with other components also. You can output to other components and other components turn, like maybe a motor and a motor will turn, things like that. So after finish the minimum components, because without the minimum components you will die, like without heart, without your whatever, you'll die, something like that. Then we also have additional standalone components like the reset button. What is reset button? The reset button is your erase button. It's over here. When you press it, all your programs will go on. Alright, it will give you an original program all along, or meaning the whole Arduino will be reprogrammed. There's nothing in there anymore. And programming interface is just simply the programming IDE, the thing that you type in the code. This is the Arduino IDE. That's what I'm talking about. Alright, this is the software for you to program your stuff. And this additional standalone component is within your controller itself. It's not something that is outside of the controller. So take note, it's just within the microcontroller also. And then we also have an external slow crystal. What is external slow crystal? Is that it looks like something like this. Alright, some clock thing, and it's used to keep track of time, as in quartz, wrist watches and whatever, but it's used to keep track of time. So therefore talks about talks about the external slow crystal. So it's talking about the time, to keep track of time. The frequency, and take note, is precision, because you want precision in your design. Alright, development systems is the system that develops your controller. So your controller is some pure piece when you buy, nothing is being programmed. So if you want to develop your program, or you want to develop your Arduino board, you need to do some development systems. So what are they? First one, computer communication interface, is just your USB port. Alright, you just plug it in. It's an interface between your computer and whatever you want to communicate. That's all. And this is not as simple as that. Maybe as talking about SPI header, JTAG. These are the things that will connect to other interfaces also. Alright, I don't go into that because I don't know anything yet, but at least something fairly useful for you to know. Some communication interfaces. Or if you want to just remember, is upload programs to the microcontroller, or communicate with the microcontroller from the PC. So your serial port monitor, I think is the serial port monitor is something like this. Alright, maybe I should off this, and then after this is your IDE. Alright, you key in your whatever thing, and then after that, when you want to look at what you have designed for your so-called the program, you can just click the serial port. Alright, there will be something of a serial port somewhere over here, I think. Yeah, the serial monitor, as you can see. Alright, if you don't see, I click it back again. So this is the serial monitor at the top. Alright, you can see that where his arrow is there. Alright, and then when you click it, this thing opens, and when you type something, the program will give you something. So this is a monitor for you to visualize your output. Alright, something like this. I'll just recommend you remember this one will do. Alright, don't remember what I've just said for the SPI header, JTAG, whatever. These are something somewhat irrelevant to us still. Alright. Hardware debugger is simply to debug whatever thing. Alright, it's debugger. I should write debugger, not bugger. Programming environment is simply your IDE, just now I show you. Alright. Simulation environment is when you want to simulate your Arduino. Alright, but however, Arduino is somewhat cheap, they say. So a simulation environment is for those very expensive one that cost about $1 million or $1,000, those types. Alright, so you can't afford, because when you put in your program, you key in your program, and then you send it to your Arduino, Arduino will output certain stuff. However, when you output certain stuff, sometimes things may cock up and your Arduino might spoil. Alright, so you need to buy new Arduino. Alright, this is okay because it's cheap. However, if you were to program something that is like $1 million, alright, and then you want to program it and then suddenly you output already the whole thing go haywire, popo, your 1 million spoil. Alright, you're gonna rebuy everything. $1 million right? So simulation environment is not is something that you need to consider, but for Arduino case it's not considered. And it's being so over here. Not widespread for Arduino due to low hardware cost. This is the simulation environment. So far so good. And how to use the SAMX, you just go and read it up. These are just simple stuff talking about its stuff. We know that it's 8-bit and 32-bit, alright, and things like that. Okay, I'm still talking about the Arduino itself. Alright, the Arduino has a standard external connectors that will connect to shields like the JTAG and the thing I've showed just now. Right, so these are the things that are all different pins. Alright, just now this one, right, the SPI header JTAG. These little connections can be connected to other modules or other Arduinos. So it isn't just one Arduino, you can have multiple Arduinos. Later on we'll talk about it in terms of the communication stuff. I just want to let you know that within the Arduino itself there are some ports, external connectors to connect with other stuff. Right, you also have a standard cross-platform IDE that is written in Java. Then you can program based on your C language, but normally you don't do that because the Arduino itself will be fine. You can convert it, alright, but normally when we do Arduino is within the Arduino codes itself will do. I mean IDE codes like you will say, but it is there for goodness sakes. And what is good about the universal language for Arduino, for example IDE, the codes, right, is because there is so many you see Arduino out there. Alright, if one of the Arduino spoil, you can actually pre-program it to another Arduino. Alright, you may take these codes from the Arduino over here and then you can transform your code to this Arduino. Alright, because all Arduinos read the same code. Alright, it's like English. If Ahmad know A, alright, if Ahmad know English, then Mas Alamat know English also, then okay, good, then you can communicate already what. So you can just bring this codes to Mas Alamat, something like that. This picture also tells you that there is many forms of an Arduino. Alright, it depends on what the uses that you want to use. Or it can be as small as a USB, it may be like a lily pad, like water lily, macam only. For what is Arduino, we have somewhat talked about it already. So how Arduino communicate? Let's talk about it now. Normally Arduino, do you, for example, one of the Arduino, which is this one over here, you can see already in your picture. Alright, it has this four stuff. Alright, what is this all about? The programming USB port is over here. Alright, just remember it's always beside the power supply. Okay, and then the native USB port is over here. So what are the difference between them? By definitions, the programming USB port is that you can connect your USB to this side, and then you can program wherever you want inside the IDE, and this thing over here will send it to the board itself. Actually, the reset button is over here. I shouldn't have said erase button over here. Dun dun. But anyway, alright, just to let you know that the reset button is here, not here. Alright, this is the erase button. Dun dun. But anyway, let's go. Once you program already, you send it to the board, this chip over here. Alright, later on there will be some lights, like I don't know where would it be a light up. So there will be some light, maybe over here, and then you will light up, or maybe over here, I don't know lah. Then you light up already, then this means that okay, you have uploaded your program into this chip, and then you can use this chip already. Alright. However, for native USB port, you are straight away code, and then this thing will straight away move. So it's not like within it's not like you program already, you send it to the board and then the board will do. It's that it's straight away program, straight away the board will output already. That's all. Alright, and these are the different things that you need to know. Alright, programming port is you require program first, send it to the board, and the board will do something. Native port, you straight away control the board without any uploading. Alright, so you straight away control the board straight away. You don't need to upload first and then do anything. Alright, because in such of the case that happens is somewhat save your time during your programming part, alright, or during your uploading part and things like that. I don't know, for you to think about it. Alright. However, because the port itself is dealing with frequencies, I think, so there will be an opening and closing of the native port at some bytes per second, that this will trigger a soft erase. Alright, that will erase some of your system, I don't know what, but and therefore may not work if the microcontroller, M series microcontroller crashes. Alright, therefore this is something that you need to know. Okay, so programming port and a native port is just such of a meaning in there. And it's programming USB port and native USB port. Okay, so when you connect your programming USB port, alright, inside your IDE, your software itself, alright, that's inside the computer, there will be some of the tabs over here you can click. So when you click already, something comes up, and then inside here there will be a programming port, and then you click this programming port, and then you can program your whatever things already. This is why it's in the slides. It says that hey, where am I? Okay, never mind. The programming port now is to talk about what is it? Select Arduino programming port. Alright, in the Arduino IDE. Same thing for the opening port, for the native port also. Okay, but just now I actually just now I say native port, I use the wrong information to tell you. But the native USB port is to connect directly to the SAM3X. Alright. And just to re-say is that a native USB port. That's why I keep saying native port. I am wrong. Alright, it should be native USB port and programming USB port. Alright, which is shown in the picture over here. The native USB port and programming USB port. Alright, it's just a port. Alright. Without the USB, alright, without the USB now, if you cancel, which is programming port and native port, it's just a program within your IDE, within your computer only. That's all. Okay, please remember that. The next thing that I just want to convey is that, say the programming USB port, alright, the programming USB port is allow you to program your stuff, alright, and when the board will flash a light and the data will be transmitted. For the USB port, you connect directly. Native USB port, you connect directly, and you can straight away control your board. Alright, and therefore your native USB board can be used as a USB mouse or keyboard to an attached computer. So when you attach it to your computer, alright, and then you pre-program it, you can use it as a mouse or a keyboard for some reason. So you don't need to program anything. You just really plug it in and then you just use it like whatever you use. Alright. Then after which you can program your programming USB port by all this stuff over here. Alright. So please do not be confused by the programming port and the programming USB port. Alright, there are two different things. Alright, within the programming USB port there is a programming port that deals with the IDE software. The IDE software will please remember that is opening and closing of the programming port connected at this 1200 bps bytes per second triggers a hard erase. Alright, so you erase your procedure in the chip, and this works when your main MCU, your microcontroller is crashed. So you want to reboot or whatever, you can use most likely the programming port. However, if your native port, then if your MCU crash, alright, it's talking about soft erase procedure only. So you can't fully erase everything. Alright, and therefore native port is not that good compared to programming port to this extent. So you need to know. And also, just to stress again, do not confuse with programming USB port and programming port, and also native USB port, which is this one, to your native port. Okay? Okay, fine. Now let's go. So we will talk about how the Arduino communicate, alright, through these USB ports, and also within its software also has programming port and native ports. Alright, and then we also can connect we can also communicate using the Arduino shields, which what we have said. If you require a speaker, alright, if you need a speaker, you connect a module with a speaker, and then you can connect it to other points. Alright, and once you connect already, you code whatever using your programming USB port, and then you upload to the board. The board will actually send some sound, and the board will actually download your codes, and then you can use your speaker already. Alright, then if you want to use a a Wi-Fi, then you use the same thing. Then you just program whatever thing inside the board, and then you can connect to your Wi-Fi, and then your Wi-Fi can work already. Things like that. Alright, so the shields is just simply other components, other external components you need to buy. Therefore, if you were to buy the other components, like for example the speaker, alright, if you buy the speaker, you have to download the speaker libraries, alright, because there will be codings that deals with how to control the speaker. Alright, what are the codes that you type inside your program? So you need to download the library, and then you have to and then you have to call the library, meaning when you type in the code, some like call or I don't know whatever, then you'll call out the speaker library, and then library will be initiated, and therefore you can use the code in the library. Alright, you can use the code in the library that deals with the sound or the speaker or whatever. Same as the Wi-Fi or whatever. So you need to download whichever libraries that you need. Alright, so they are all open source in the Arduino. And for the breadboard, alright, we last time say that this line is the minus, this line is the plus. Alright, and all of them are connected horizontally, so they are like circuit is horizontally. As for this part over here, this middle part are all connected vertically. Alright, they're all connected vertically by A, B, C, D, E, F, G. Alright, so just take note that for these two pieces over here, they are connected horizontally. For the middle part over here, they are connected vertically. Alright, these are the things. And inside your PDF, you also are given your pinout diagram. Your pinout diagram tells you that which pin will give you which pin. Alright, what are the pins that talks about which pin. Alright, in total there is 54 pins. Alright, what are the 54 pins? These are all pins. Alright, wait these little stuff are all pins. If I have to zoom in more properly, these are all pins. The 1, 2, 3, 4, 14, 26, these are all pins. There is 54 of them. Alright, but however there is 12 of them are analog. Alright, 12 of them are analog inputs that is being specified over here. I think these are the 12, or maybe you can calculate lah. Alright, but there is 12 analog inputs and 12 analog outputs. I think by the name of A. Alright, by the name of A1, A2, A3. Analog in, and I don't know where's the analog out. Something like that, I think. DAC, whatever. Yeah, digital to analog. Yeah, so these are the 12 path. Alright, A1, A2, A3 to A whatever. Okay, I think you know what I mean already lah. And therefore it's about 12 analog input pins and 2 DAC output pins. Sorry, so it's 2 AC, DAC. Alright, so I think this thing over here you may need to remember, because it's talking about how many pins you want in your design. So normally when you choose your design, you have to ensure that the pins are enough for you to choose, because if you're talking about 100 pins, then your Arduino deal is not able to support, and the voltages that you may need to remember also. Alright, these are the little things that you may need to take note. And before I go, I just want to talk about the COM port also, and also the serial monitor. Alright, because I think I need to brief on it. The COM port itself is that normally when you input your USB, right? When you put your USB, and then there will be some icon coming up. Alright, so there will be some COM port stating that there is COM port, and that's it. This is just the COM port. Alright, so if you read past and then you don't know what is COM port, this is just to tell you that the software is connected to your computer, things like that. Alright, as for serial monitor, if you remember just now I showed you that the particular video is to show you your this thing over here, right? And therefore this program, that after you click the serial monitor, alright, once you click this serial monitor, this thing will come out. What is the purpose? Is because you want to troubleshoot your stuff. If you have a huge program and you want to look at the output itself and to debug it. So therefore the serial monitor is a very important thing you need to also take note of. Alright, serial monitor. So yeah, so these are the things that you may need to know, and I wish you luck soon. Alright, goodbye.